So let's think about this interference pattern of light in terms of a chem quiz. So if you shine, say, green light and you obtain this two-slit interference pattern, how would that interference pattern change if you increase the wavelength lambda? So you go from, say, green light to red light, longer wavelength light. How will the interference pattern change? Will the pattern get more compact? Will it look about the same? Or will it get more dispersed? Think about that for a second and make a selection. Let's consider three possible explanations for the three answers. A, increased wavelength causes higher frequency spacing since wavelength and frequency are inversely proportional. Or B, the interference depends only on the spacing between the slits. So increasing the wavelength doesn't change anything and no change should occur. Or C, longer wavelength light causes destructor interference at larger intervals along the wall. Think about those three options and make another selection. When you change the wavelength in a two-slit experiment, what do you expect will happen? Well, what we know from our two-slit wave interference pattern is two slits cause a high intensity then low intensity because the paths are equal right between the two slits. But if you go to the first peak, say, then one wave has to travel farther than the other, and it's that extra distance that causes either constructive, a bright spot, or destructive, a dim spot, interference on the screen. So the larger the wavelength, the larger this spacing will be. That is, you have to move farther up the screen to make this path length long enough to get an extra half wavelength and give you constructive or destructive interference up the screen. So longer wavelength means a spreading out of the diffraction pattern on the screen, and the correct answer is C.